Welcome, and I'm so glad you're here. The plan for this video will be to make sure that we are open to this document called Remediation, page 7 in Class Kick. And while this video is playing, you can watch and you can take notes while this is happening. And then we will go to the next page and you'll have a chance to do your practice, and your teacher will give you a chance to get feedback, followed by giving you a chance to get a passing grade on this Unit 9 test. So let's begin. So for problem number 1, when I see a graphing problem like this, my first step is going to be to start with labeling my A's, B's, and C's. So always make sure you're including the sign before, not just the 4, but the plus that's in front of it. Because when we're doing the C, we need to make sure we're including that it's a -2, not just a plain old 2. All right, so now that I have my A's, B's, and C's, I'm going to work on trying to figure out the x-coordinate for the vertex. So this formula is the formula that I always use to figure out the x-coordinate of the vertex. X equals the opposite of B over 2A. And so since my B value is going to be 4, then the opposite of a positive 4 is a -4. And that's going to be all over, it's always going to be 2. And then since my A value is going to be a 2, I'm going to do 2 parentheses 2. All right, so I'm going to figure out the value of that. I'm going to calculate the denominator. So I'm going to multiply 2 times -2 and write that out. And now I can just divide -4 divided by 4. And that's going to be a -1. Okay, so now that I have that, I can go to my table, and this -1 is going to be the middle x-coordinate for my table. So I'm going to put that in just like that. Okay, now I can work on trying to figure out the y-coordinate for that vertex right there. So I am going to take my -1 and I'm going to substitute -1 in for each of these x's. And so here's what it's going to look like. It's going to be y equals 2. Instead of 2x squared, it's going to be 2 parentheses -1 squared. And then instead of plus 4x, it's going to be a plus 4 times -1. And then minus 2. So now I'm going to put this expression into the calculator, and whatever the output is, that's going to be the y-coordinate of my vertex. Okay, so I'm getting a -4 as an output. All right, so that means that I can go to my table, and I can put that the output of -1 is -4. So now I can put in the numbers that surround -1. All right, and to figure out my outputs, I can go back to my calculator, and I'm going to, maybe if I want to work on my -3, the output for -3, I can just change my inputs to -3s. And I can see that that's going to make a +4. Okay, so there's a 4 right there. And then since this output is going to be a 4, then the other orange output is also going to be a 4 also. All right, now for my red numbers, change those to -2s. And it looks like I'm getting -2. Coincidence, that's the same number. Not always going to be the case. Okay, so now that I'm done with my calculator, now I can go ahead and graph the points. So I always like to start with my vertex first. So -1, -4, the purple number right there. That's going to be go left 1 and then down 4. At any point, if I'm going too fast, you need to pause the video, feel free to pause the video and replay things as many times as you need until you're able to get what you need. Okay, now I'm going to do my red points, -2, -2, and 0, -2. And I'm going to do my orange points. So -3, +4. That's left 3 and up 4. All right, so there it is. So now I can go ahead and draw in my parabola. I'm going to start at my vertex, the purple point, and I'm going to make it curvy so that it goes up and to the right. It never goes straight up. It's always going up and in one direction. So it's going curvy, it's going up and to the left is what my parabola is going to look like. Okay, now let's do some analysis. So what direction does the parabola open? I can look at the parabola to see that it's opening up. My axis of symmetry is going to be this dashed line that goes down the middle of that parabola. And so that's going to be x equals -1. The vertex is going to be the purple point. That's going to, you can look at I can look at the table if I want, or I can look at the parabola to get the coordinates -1, -4. And then for this question about, is the vertex a minimum or a maximum? I'm looking at this vertex and I'm seeing that this vertex is the lowest point on the graph. So since it's the lowest point on the graph, that means it's going to be a minimum point. All right, time to move along to problem number 2. So we can read the directions. Okay, so this y equals x squared. This is like the parent function. So it's going to have a vertex at the origin, and it's going to have a normal width, not too narrow, not too wide. We'll come back to determining number of zeros in just a little bit. Okay, for part B, y equals x squared plus 4. This plus 4 means I'm going to move up 4. So that's where my starting point is going to be about right there. And since it's a plain old x squared, it's still going to be a parabola that opens up. All right, part C. So this one we have a +5, so that's why I'm going to be starting up 5. And then because we have a negative in front, this means that this parabola is going to open down. And now for part D, y equals x squared minus 5. There's the -5, and then x squared means it's going to open up. All right, so now we can answer the question about stating the number of zeros that each of these functions have. So 0 means how many times that these functions cross the x-axis is what they're looking for right there. Just the number of times, not the actual locations. So for this part A graph here, this graph, it looks like it intercepts it at 1 point. So that's why it's going to be 1, 0 is what I'm going to put right there. For part B, there's that x-axis, and this one does not intersect at all. So it has no zeros at all, so 0. Part C, looks like this one has 2 different places where it crosses the x-axis, so 2 x-intercepts or 2 zeros. And then part D, this one also looks like it's going to cross at 2 different spots, so that's why this one has 2 zeros for me also. All right, let's talk about a couple of other transformations, and then we'll get to our last type of problem. Okay, describe the transformation that occurs when the graph y equals x squared is changed to, we'll start with part A, y equals 3x squared plus 2. So for me, I'm always going to start with looking at the number at the end here. This is the up or down number. So since this is a +2, I'm going to write that this is going to move the parabola up 2. And then the other thing I look at is I look at the number that's in front. So since there's a number 3, anytime there's a number that is greater than 1 in this purple spot right there, that's going to mean a more narrow parabola. And that's going to be in comparison to the next one here, where if you have a number that's in front that is between 0 and 1, then it's going to be a wider parabola. Okay, so but first, let's talk about the -1 is going to mean down 1. And then the 1/2 is going to mean wide. All right. And then part C, the +8. This is going to mean to move the original parabola up 8. There's a negative in front of this one here. Look at this. So that orange negative right there means it's going to open down. And then that 5 that's in front is going to mean that it's going to be a narrow parabola. Remember that number in front, since this 5 is a number that's bigger than 1, then that's why it's going to be more narrow. All right, talk about the last one here. Remember, we're trying to take notes so we can get our practice and effectively make up our test so that we can get an appropriate grade on our test. Okay, So for graphing this equation right here, this is called intercept form, and they're going to ask us, the things that they're asking us to figure out over here is going to help me with making my graph over here. Okay, so for x-intercepts, whenever I see x-intercepts, I'm thinking set y equal to 0 for this original equation. So I'm going to go ahead and rewrite the equation over here and set y equal to 0. So instead of y equals, it's going to be 0 equals, and it's going to be the quantity of x minus 3 still, times the quantity of x plus 1. Okay, so to solve that equation, we can use zero product property. So the way I like to do is I like to think about it as two different numbers here. Pink times blue equals 0. If pink times blue equals 0, then that means that either the pink number must be equal to 0 or the blue number equals 0. I'm just going to solve both of those equations. Okay, so there you go. Those are my x-intercepts right there. Some teachers might want you to write down as an ordered pair, so if your teacher asks you to do that, you can do that too. Okay, so I'm going to go ahead and graph those points. So these are the points along the x-axis right here. So I'm going to graph x equals 3, just done in pink, and x equals -1 is in blue. Okay, next thing they want us to find is the y-intercept. So for the y-intercept, this is we're going to set the x equal to 0 for our original equation and solve it. So the new black equation, it's going to be y equals, if I put 0 in for x, it's not going to be 0 minus 3, or x minus 3, it's going to be 0 minus 3. And then instead of x plus 1, it's going to be 0 plus 1. And then we can evaluate this expression in the calculator. Okay, it looks like it's saying -3. So my y-intercept is at y equals -3, or it's the point 0, -3. Okay, so that point is graphed right there. Okay, I'm going to skip the opens up or down for right now. I'm going to go directly to a vertex right here. So for a vertex, the way that I like to do this one here is I'm going to look at my 2 points right there and try to figure out where is the middle between these 2 points. And I can see it's about going to be about right there. So this is going to be the axis of symmetry. So if you want to zoom out, let's have you draw in, along with me, this dashed line, the axis of symmetry. This will give us some good information about our parabola, for sure. Okay, so I always ask my students, what number is this point at here? If we start at the origin, and if we go right 1, that's going to be a positive 1. So for me, the vertex is going to be +1, comma something. So to figure out the output, we just need to figure out what is the value of y when we substitute 1 in for each of these x's. So if I go back to my calculator, if I recall the previous line, I can change all my inputs from 0s to 1s. And it's a -4. So I wrote that in. Okay, I'm going to graph 1, -4 right now. It's that big green point that's right there. All right, another purple point right over there too. And it's time to graph the parabola. So remember, curvy and going up and to the right, curvy going up and to the left. This is going to be my parabola. The direction this parabola opens, I can see that it opens up from looking at it. And then the axis of symmetry, I can get the axis of symmetry from looking at the vertex. It's always going to be x equals, and it's always the x coordinate of the vertex is what I do. Or you can look at this dashed line to see where the location for that axis of symmetry is going to be at. All right, so that concludes our notes. If you missed anything, you can rewind the video and rewatch and rewrite anything down that you need to. And then the next step that your teacher will have you do will be to go to the next page on ClassKick and to work on your practice. It's been fun hanging out with you. Hope you have a nice rest of the day. Bye-bye.